we feel really honored by having won the first edition of the PV Magazine Award for projects when we started 2019 with this innovation. It would have been a dream to get into here. So we really thank you so much for appreciating the approach for local assembly of cooling solutions and for awarding one of our sites in Kenya.
Really happy to receive this award. I mean, the topic of solar cooling is not so well known, and it's really important to push this topic to the public, and I hope this award will bring us some publicity for this topic of solar cooling technology. The self-chill cold room is a walk-in cold storage container. So you can cool any kind of products, especially products from the agricultural sector like fruits, vegetables, or any other kind of produce to a specific temperature. It's a complete system that's independent from any infrastructure because it's powered by solar, and it also has its unit to create the cold and to store the cold, the water chiller. So it's a complete system to cool any kind of products. The project PV Cool Kenya, it was a joint project of the company Phaesun, Solar Cooling Engineering, and the Strathmore University in Nairobi, Kenya. So it targeted the implementation of solar cooling systems in the agricultural sector in Kenya. So we have implemented 3 pilot systems. So one cold room for a herbal farm, one milk cooling system for a dairy farm, and an ice maker to cool fish. Actually, in addition to the implementation of those pilot systems, we operated trainings on solar cooling technologies together with the Strathmore University. And it was a 2-year project, and we could work together with very different stakeholders in Kenya, from the agricultural sectors with farmers, but also from the educational sector with the university and their students and technicians.
Yeah, that's a really, really easy system to understand. Basically, we have a small DC cooling units, and these cooling units cool down water in an insulated box. This insulated box builds ice out of surplus solar energy, and then this cold water is circulated by a DC water pump into a heat exchanger. It's like a fan coil, and from there we transfer the coldness of the water into the air of the cold room. So the system is fully modular and is able to be adapted to any size of cold rooms. If the cold room is bigger, then the thermal storage will be also bigger. We will have then more cooling units, therefore the modularity. Yes, that's a very interesting advantage. So the use of small-scale cooling units that are driven by direct current is very interesting because this makes the installation very easy and very safe due to the fact that you don't have high voltage in the installation. The maximum voltage we have is 45 volts. And this is released from high voltage safety regulations. This means every technician can build a self-chill cold room. The system doesn't require any inverter, and in fact can run with conventional charge controllers and batteries, which are commonly used in rural areas also for solar home systems. So the knowledge how to install a self-chill cold room is already given in rural areas. And since the cooling units are filled with refrigerant already from the factory, and they have a capillary tube similar to household refrigerators, then you don't need any refrigeration technician. There is no need to add gas, to add refrigerant into the system. So this is the advantages of using the DC cooling units compared to higher refrigeration systems. Yes, this is a very important factor for us. You know, we are committed to solar energy, we are committed to sustainability. And when talking about sustainability, the use of refrigerants with a very low global warming potential is very essential. Otherwise, the refrigerant in the in the cooling device, once it is lost into the atmosphere, will create a bad environmental impact, and that's why we're committed to use only natural refrigerants. In our case, we use isobutane R600A, which is very well known for its high efficiency and commonly used worldwide in household refrigerators. In our case, it is also not required to fill the gas during the whole lifetime of our cooling units. And even though natural refrigerants are inflammable, in our case, by using isobutane, this is the case, but because our cooling units are small and only have 35 grams of refrigerant, this doesn't represent any safety problem at all in our installations. In fact, the cooling units can be transported by plane and road is in a similar way than household refrigerators.
So actually our cooling systems are implemented together with smallholder farmers in rural Kenya, and they are used in different agricultural value chains to cool herbs, fruits and vegetables, and fish and milk. And this means that they are used to extend the lifetime of the agricultural products and to reduce post-harvest losses. And they really bring additional income to the users. So in the case of the cold room, it's used by a herbal farm. So they produce basil, mint, and other herbs, and they put the harvest directly into the cold room. Otherwise, it will turn bad. And then they store the herbs in the cold room until they are collected by a cold truck. And they produce the herbs for local markets and also for export, and they could really increase their income by using this cold room. Otherwise, their business model, how they run it today, would not be possible. So the same with the milk cooling system, where at the dairy farm they can extend the lifetime of the shelf time of the milk, and they can also produce higher quality products with the cold milk. So they really preserve food, and they can really create higher quality products and increase their income. So another aspect of this project is that our cold rooms can be constructed locally. So we only send the core components to construct the systems, and the rest can be done by local personnel and local technicians. So it's not the Germans going to Kenya and installing the cold rooms. It's mainly that we send core components. A lot or big parts of the systems are sourced locally, so they can buy insulation material and other components for the systems in Kenya, and then the technicians that are based in Kenya can construct the system. So a big part of the value chain also stays in Kenya and not in Germany.
Yes, the biggest challenge while designing a solar off-grid system, which is not connected to the national grid, is always to find a compromise between the autonomy of the system. So how many days can run without solar energy, and the investment cost. In the case of cold rooms, this is even more challenging because the actual energy consumption highly depends on the ambient temperature, even more than on the solar irradiation. And on top of this, the energy consumption is also highly affected by the way the system is used. For example, the rate of utilization. This means the amount of products stored per day in the cold room, and also the set point temperature. So which temperature has to be inside the cold room. And they affect the daily energy consumption and the whole design of the system. And in this case, what we did it is to use the thermal storage that helps a lot to compensate those fluctuations that we have in not only solar radiation, ambient temperature, and the amount of products entering the cold room. This makes the overall system to be much more robust and to be able to run off-grid 24/7. The system might work at higher temperature, so the cold room temperature might go a little bit higher if many products are entered at the same time into the cold room, but it will never stop. a system with electrical batteries, that sometimes the batteries will be empty and then stop providing coldness, but this doesn't happen with our system because of the support of the thermal storage that adapt to those fluctuations. Yeah, so far we have been able to reduce the overall cost of solar cold rooms by introducing a considerable number of local source components. This is part of our soul of the self-chill vision and mission. In comparison to containerized cold rooms imported from abroad, we have at least 50% less capital cost. This is a good success, and we are currently supporting the operation of cooling systems in 7 African countries, and focusing a lot in potential user cases that are able to generate income within agricultural value chains that didn't have access to refrigeration before. And this is a very promising and exciting field, because you are really bringing access to refrigeration to places where no refrigeration was there before. This brings adaptation of the agricultural value chain and a lot of potential to generate income, so that the investment cost of cold rooms is covered within a short period. The key markets are cold rooms at marketplaces, also aggregators of agricultural produce, and medium-scale farmers, as in the case of Thika in Kenya. The value chains are fruits and vegetables, but also the fish and dairy value chain has a high potential. And besides our focus on off-grid systems, we see a high potential of growth in the solarization of existing cooling facilities. These existing cooling facilities are normally run by the national grid or by diesel gensets, and the substitution here of inefficient cooling devices by more sustainable ones. This, in combination with solar energy or electrical batteries, thermal storage, is a key to increase the sustainability of the cold chain in rural areas. So this is a market we are willing to focus also in the next years.